Number one, for which of these angles is the sine negative? So if we think about the unit circle, remember that the sine is the y values. And the unit circle is kind of like the coordinate plane, right? And so these would be positive x, positive y, negative x, positive y, negative x, negative y. So sine would be negative here. And then positive x, negative y. So sine is going to be negative down here because this is where our y values are negative. So any angle that lands in the third or the fourth quadrant would be a negative sine value. So if we look at where negative pi over 4 would be, negative pi over 4 would be here. So that's going to be in quadrant 4. So this has a negative sign. Negative pi over 3. So negative pi over 3 will be here. So that's also in the fourth quadrant. So the sign would be negative. Negative 2 pi over 3. So here's 1 pi over 3. 2 pi over 3 would be here. So negative 2 pi over 3 would be in the third quadrant. Sign would be negative. Negative 4 pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3. So negative 4 pi over 3 would be right here. And that is in the second quadrant. So the y value would be positive, or the sign would be positive. Negative 11 pi over 6. So all the way around this way would be negative 12 pi over 6, okay, because 2 pi is equal to 12 pi over 6s, since 12 divided by 6 is 2 pi. So all the way around clockwise would be negative 2 pi. So negative 11 pi over 6 is going to be right here, and that's going to be in our first quadrant, so that is going to have a positive sign. Number 2, the clock reads 3 p.m. Which of the following are true statements? Select all that apply. In the next hour, the minute hand moves through an angle of 2 pi radians. So let me get the minute hand on here. So here's the minute hand. And if we follow a clock, the minute hand goes this way, right? So that is a clockwise angle. So in math, a clockwise angle would be a negative angle. So this is going to be that the minute hand goes negative 2 pi radians, not 2 pi radians. So this is false. In the next 5 minutes, the minute hand will move through an angle of negative pi over 6. So from here to here. And that's true because every angle, every number on the unit circle, if we think of this as being pi, right? So halfway around is pi. Every half of the clock is split into 6 hours. So every one kind of hour between here is a pi over 6 width. And so if we're going clockwise, from 12 to 1, that would be a negative pi over 6 movement. So this is true. After the minute hand moves through a negative pi radians, okay, and pi would be halfway around, so half of a rotation. So negative pi radians, the time is going to be 3:30, and that would be true. So it's just going to be a half hour ahead. And remember, it started at 3 o'clock, so 3 o'clock and then 30 minutes ahead. When the hour hand moves through a time, so the hour hand is going to go negative pi over 6 radians. Okay, so clockwise 1 hour, it will be 4 o'clock. That is true. The angle the minute hand moves through is 12 times the angle that the hour hand moves through. And that would be true because the minute hand, for every time that this moves 1 hour, the minute hand moves 12 of those. So when this moves to here, this has to go all the way around 12 of those. So that angle is going to be 12 times as large as the hour. Number 3, plot each point on the unit circle. So this is cosine of negative pi over 4, sine of negative pi over 4. So we're going to look at this angle here and plot that point. And so that's going to be negative pi over 4 here. And I'll just, we can just label it A. So that would be cosine negative pi over 4, sine negative pi over 4. So that's A at negative pi over 4 angle. B wants us to be at 2 pi. So 2 pi is going to be the same as 0. So that one's here. C is at 16 pi over 3s. Okay, so 16 pi over 3s. And I'm going to take a line segment here to count this. So pi over 3, remember, that means each pi is split into 3. So this would be 3 pi over 3, 6 pi over 3, 9 pi over 3, 12 pi over 3, 15 pi over 3, 16 pi over 3. Okay, so that's going to be right there for C. So again, like this is pi, right? But in thirds, so that's 1 pi, but in thirds, that's 3 pi over 3. And then this would be 2 pi, which is the same as 6 pi over 3. So then every time I went a half rotation, I just added another 3 on. So 3 pi over 3, 6 pi over 3, 9, 12, 15, 16 pi over 3s. All right, then the last one here, 16, negative 16 pi over 3. So now we're going to do basically the same thing, but go backwards. So negative 3, 6, 9, 12, 15, 16. So negative 16 pi over 3. So this time we were going clockwise. So 3 pi over 3, 6 pi over 3, 9 pi over 3, 12 pi over 3, 15 pi over 3, 16 pi over 3 for that one, negative. Number 4, which of these statements are true about the function f of theta equals sine of theta? Select all that are true. The graph meets the x-axis at 0 and then plus or minus pi, 2 pi, 3 pi. So let's think about the sine function. And remember, it's going to meet the x-axis, meaning that it equals 0. So that's going to be where the function equals 0. And sine is our y value. So here, this ordered pair is 1, 0. So the y-coordinate would be 0. Here, it's negative 1, 0. So the y-coordinate would be 0. And that's at pi. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So yes, you could also go backwards. Negative 1 pi, negative 2 pi, negative 3 pi, and so on. So this would be true. The value of f always stays the same when pi radians is added to the input. So let's take a look at just a point on the unit circle. So if we looked at, let's just do this one. Okay, this one is the point 0.71, 0.71, right, at 3 pi over 4. And then if I add pi units onto here, I'd be down here at 5 pi over 4. Oh, sorry, 7 pi over 4. And at this ordered pair, it's 0.71 comma negative 0.71. And so the y-coordinate or the sine value changed with a pi rotation. So this is false. You can also look at that in the graph of sine. So if we looked at the graph of sine, so if you looked at, like, here's pi over 2 even, and here's 3 pi over 2, that's halfway apart, and now it's down here, or a pi unit apart. So this one's at 1, this one's at negative 1. So it does not stay the same every pi radians. The value of f always stays the same when 2 pi is added. Well, that's true, because that's just a rotation that gets you right back to the same number. So if we started here and we added 2 pi, we'd be back here. If we started here, add 2 pi, we'd be back. Here, add 2 pi, we'd be back. So that's true. Every 2 pi is a coterminal angle and the same sine value. The value of f always stays the same when negative 2 pi is added. Yep, that's just a backwards rotation. So instead of going counterclockwise, you'd be going clockwise, still end up right here, still end up here, still end up here. So 2 pi is just one rotation, whether you go forwards or backwards. And then E, the graph of f has a maximum at 5 pi over 2. Okay, so let's find where 5 pi over 2 is. Remember, that's every kind of one of these is a pi over 2. So this is 0 pi over 2, 1 pi over 2, 3. Oops, I said that wrong. 0, 1, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So here's 5 pi over 2 is sine at a maximum. And it is because it's at 1. So this is true. Number 5, here's a unit circle with a point at 1, 0. For each positive angle of rotation of the unit circle around its center that's listed, indicate on the unit circle where P is taken and give a negative angle of rotation that would take P to the same location. So for this first one, we'll start at pi over 4. So pi over 4 is halfway between 0 and pi over 2, so right here. So here's pi over 4. And then a negative rotation, so I like to just think of what 2 pi is with the denominator that we're working with. So we're working with a 4, so that's going to be 8 pi over 4 because 8 divided by 4 is 2. So then the negative rotation will total up to that 8. So this is going to be negative 7 pi over 4 because 7 and 1 gives you 8, a full rotation. B, so at pi over 2, so here's pi over 2. So this is for point B. And again, 2 pi in pi over 2's is going to be 4 pi over 2 because 4 divided by 2 is 2. So then this one is going to have a negative angle of rotation of negative 3 pi over 2 because 3 and 1 gives you 4. Pi, so here's pi. And then this would be a negative pi. So 1 and 1 gives you 2 pi. So pi this way or negative pi that way gets you to the same spot. And then 3 pi over 2. So 3 pi over 2 is here. So that's the positive 3 pi over 2 rotation. And so now that's going to go with a negative pi over 2. So if we go 3 pi over 2 this way or we go pi over 2 backwards, we would get to the same spot. Number 6, in which quadrant are both the sine and the tangent negative? So remember that sine is your y value. So this is the y values, and y values are negative just in this bottom set of quadrants. So that's quadrant 3 and 4. So let me label these. So this is 1, this is 2, this is 3, and this is 4. So the y values are negative in the bottom half, right? So that rule brings us down to quadrant 2, 3, and 4. So we're definitely not in the first or second because sine is positive up there. Then we want to be looking at tangent. And remember, tangent is the y value divided by the x. So we, in this quadrant, the x and y are both negative. So if we do a negative number divided by a negative number, that means the tangent would be positive in this third quadrant. Where here we have a positive x and a negative y. So when we do a negative divided by a positive, that gives us a negative number. So tangent is going to be negative in the fourth. So both tangent and sine are negative in the fourth quadrant. Number 7, each equation defines a function, graph each of them, and identify which of them are periodic, and then select all that are true. So I'm not going to graph these, but I'll just draw you a quick sketch of each of these, of what it would look like if you were to graph it. So the sine function is going to look like this, right? So that is periodic. It goes high to low, back to high, low, and goes through a pattern. So, and continues that pattern on forever. So that one is periodic. The e to the x function looks like this. So that one starts low and just keeps getting high. It's never coming back down or going back up. So that one is not periodic. Part C is a quadratic and x squared. So that one's going to look like this. So it's going to go down to a minimum and come back up, but then it's never going to go back down again and back up. So this is not periodic. Part D is the cosine function, looks exactly like the sine function, just starts at its maximum. And so this one is periodic as well, goes from max down to min, back up, and so on. And then finally, y equals 3. That looks like this. Now, this one's kind of interesting because it's not like it's going up or down, but it is just following a pattern the whole way through. So this one actually is periodic. Unlike this one that keeps going up and never comes back down, or like starts up, then goes down and back up. This one that just keeps going up. This one stays at 3, so it keeps doing the same thing the entire time, so it is considered periodic. Number 8, list 3 different counterclockwise angles, so positive angles of rotation around the center that takes P to Q. So here's P. The first angle that would take us to Q would be pi. So then we could do another full rotation, and that would be 3 pi. And then we could do it again and get 5 pi. So there's 3 angles, any odd value of pi. So even if you did like 291 pi, that's going to land there because it's an odd number. So any odd number with pi will land you from P to Q. Which quadrants are the angles 13 pi over 4 and 10 pi over 3 in? And then what would the sign of those be? Would it be positive or negative? So again, when we have this 4 in the bottom, so I like to think of this as 4 pi over 4 because 4 over 4 is 1. So I like to count like that, and then this would be 8 pi over 4, and you'd keep adding 4 pi over 4s. So this one would be 4 pi over 4, 8 pi over 4, 12 pi over 4. So 13 pi over 4 is going to land in here. And then if I do pi over 3, then this would be 3 pi over 3. So this would be 6 pi over 3. And we'll count like that. So 3 pi over 3, 6 pi over 3, 9 pi over 3. So 10 pi over 3 is going to be in this third quadrant as well. So these are both in the third quadrant. And it wants us to then tell if the sign is positive or negative. Well, that's the y value. And in the third quadrant, you have negative x's and negative y's. So the sign is going to equal a negative number.